Hello, thank you for watching this video. So in this video, we'll be doing question 2 of November 2023 question paper mathematics paper 1. And these are cubic functions. So I'll read the statement and then proceed to answer the questions that follow. So question 8, read as follow. Given f of x to be this equation here, this equation or this equation. So we're given that f of x is this equation. When it is factorized, it is this one down here, right? So that's all they gave you. So you are given this cubic equation. Let's go. 8.1 read as follow. Determine the coordinates of the turning points of f. So they want you to find the equations of the turning points of f. That's what they want you to find. So you are given that f of x is equal to minus x cubed, right? Plus 6x squared minus 9x plus 4. So this is the equation for f that they give you. So what they want you to do, they want you to find the coordinates of the turning point. They want to know where the turning points are. So what do you know about the turning points? At the turning points, you know the gradient, right? It's called what? It's called 0. Because at the turning point, your graph is turning, right? So if you draw a tangent there, it will be horizontal. So you know that the gradient of a tangent at a turning point is 0. Even if it's turning maybe down here, the only gradient that you can draw there will have a horizontal. The only tangent that you can draw at the turning point will have a gradient of 0. So what you know is that at the turning point of a function, the gradient is 0, right? No problem. So we know that where f turns, the gradient is what? Is 0. So how do we know, how do we find a gradient? Right? It depends. Do you want an average gradient or you want the instantaneous gradient? So now, but we don't want any average gradient. We want the gradient at that point. Right? So you know that the derivative of a function, if you find f prime, which is the derivative of f prime, it gives you f prime at x, which is the... So I'm saying, if you find f prime, which is the derivative of f with respect to x, this gives you what? The gradient at point x. So a derivative of a function gives you a gradient at a point, right? So in our case, we can find the gradient. We can find the derivative of f, right? So the derivative of f is what? F prime is equal to, what do you do? Say 3 times negative, so we have 3 times negative 1, right? X raised what? 3 minus 1, right? Plus, say 2 times 6, so we say 2 times 6, x raised 2 minus 1. Then you have 1 times 9, 1 times, so we have minus 1 times 9. So x raised 1 minus 1. Then the derivative of that is 0, of a constant. So what do you have? So we have f prime, which is the derivative of f with respect to x, equal to minus 3x squared plus 12x minus 9. So this is the derivative of f. I said that a derivative of a function gives you a gradient at a point, right? But, so which means this equation, if you substitute 2 here, you will know what exactly the gradient is at x is equal to 2. If you substitute your 7 here, 7, 7, you will know exactly what the gradient is at 7. And that gradient is the gradient that your tangent at x is equal to 7 will have. So it's the gradient at a point. So what do we do? So in our case, we say we want the coordinates of the turning point, right? So the turning point, we know where the gradient where the function turns, we know that the gradient is what? Is 0. So which means this part gives us a gradient at a point, right? This part gives us a gradient at a point. But we know at that point the gradient is 0. because we know that our cubic function have two turning points. So in each of those turning points that we have, the gradient is 0. So what do we say? So we say, okay, we know that the value of this thing, which is minus 3x squared plus 12x minus 9, it should be 0 at the turning points. Because at this, we know that f prime, which is this, is a gradient at a point, right? But at our point of interest, which is the turning points, we know the gradient is 0. Which means this thing, the whole thing should be 0. Because it is our gradient at those points. So we want to know what are those points that gives us the gradient of 0. Right? So if we solve this equation, the points that we will get, or the solutions of this equation, are the points where the gradient of our function is 0. So let's go. So what do we do? So we take out the common factor, minus 3, or you can use the quadratic equation if you're comfortable with it. Minus 4x plus 3 is equal to 0. Took out negative 3. So this time this minus 3x squared, this time this plus 12x, this times that is minus 9. So minus 3, you can factorize this, or you can use the quadratic formula straight away. X, you have 3, you have 1, you have minus, you have minus. So if the product of this, if you multiply two brackets and the product is 0, which means at least one of them is 0. So x minus 3 is equal to 0, or x minus 1 is equal to 0. At least one of them should be 0. If the product of two brackets is 0, at least one of those brackets should be 0. So either x minus 3 is equal to 0 or x minus 1 is equal to 0. Then you solve for your x. Your x is equal to 3, or your x is equal to 1. So these are the x coordinates of the turning point. At these x values, the gradient of your function is 0. At x equal to 3, the gradient of this function is 0. At x equal to 1, the gradient of that function is 0. How do we do this? We said we have the equation to be this, right? And we said the derivative of this gives us a gradient at a point. So we found the derivative to be what? Minus 3x squared plus 12x minus 9. So this gives us a gradient at a point, right? But we know at the turning point that the gradient is 0, which means this thing is equal to 0. Then that gives us those x values which exist at a gradient of 0. That's how we did it. So we have the x coordinate. Then to find the y coordinates, you need to find f at 3, which is equal to what? It will be 3 minus 1 all squared minus 3 plus 4. This is f at 3. So f at 3 is equal to, what is this? So this is 1, right? And what is this? So this and this, so this is 4. So the product of this thing is 4. Because this is 3 minus 1 is 2, all squared is 4 times 1. So your coordinates are 3 and 4. These are your coordinates, right? For the next one, do the same thing. We say f at 1, because we want to find the corresponding y value, is equal to 1 minus 1 all squared, 1 negative 1 plus 4. So this part is 0. So if you at least one, if the one of the brackets is 0, which is the product is 0. So the coordinates are 1 and 0. So your coordinates of the turning point, this is the first one, and this is the second one. Done. Go to the next question. What are they saying on the next question? So it's 8.2. I hope the first one is clear. So we move. They are saying at 8.2, draw a sketch of f, right? Clearly label the intercepts with the axis and any turning points. Let me read this again. Draw a sketch of f, right? Clearly label all the intercepts with the axis and any turning points. So they want you to draw this function. They want to sketch this and label all the intercepts with the axis, right? And the turning point. So you know the turning points at 3 and 4, 1 and 0. So these are the turning points. So y-intercept, where your graph cuts the y-axis, you know that x is equal to 0. You know that x is equal to 0. So, which means, if you want to know where your function cuts the y-axis, you must find the corresponding y value of f at x is equal to 0. So, you must find f at 0 is equal to what? Equal to 0 minus 1 times negative 0 plus 4. Right? It's all squared here. So this is 1, this is 4, so this is 4. So your coordinates, your y-intercept is 0 and 4. Done. Then, what do you need next? You need your x-intercept. Where does your graph cut the x-axis? You know that y is equal to 0. Then what do? You say, okay, x minus 1 all squared, and minus 4 minus x plus 4 is equal to 0. Because this was equal to f of x, right? And f of x is what? Is 0 because it's your y. This is y. It's the y value of f. So what do you do now? So x minus 1, x minus 1 minus x plus 4 is equal to 0. So x is equal to 1, or x is equal to 1, or x is equal to 4. These are x-intercepts. So the coordinates for your x-intercepts is 1 and 0, 1 and 0. And other one is 4 and 0. So these are intercepts. Then, now the next step is to plot our function. So let's try to do that and see how that goes. So we say our function looks like so this is the line x is equal to 0, this one, because along this line x is 0, this is the line y is equal to 0 here, right? So what do you have? You have the turning point at 3 and 4. Let's say we have 1, 2, 3, 4. 1, 2, 3, 4, right? And then 3 and 4. So 1, 2, 3, 4. 1, 2, 3, 4. So the coordinates of 3 and 4. Also, they are somewhere here. This is the turning point, this one. And the other one is at, another turning point is at 1 and 0, which is here, it's on the x-axis. Right? This is another turning point. What else do we have? We have the y-intercept at 0 and 4. X is 0 here, and y is 4 there. So here we go. What else? We have that x-intercept there, which is this one here. So, if you can plot our function f, it looks like something like this. Something similar to this. Not very nice looking, but you get the point. It looks something like this. So this is your function f. So we have shown the x-intercept, we have shown the y. X-intercept, shown the y-intercept, shown the turning points. Yeah, we should be fine. So that's how it looks like, more or less. So go to 8.3. Okay, so now we're done cleaning the board. We're going to do 8.3. So 8.3 reads as follows. Use the graph to determine the values of k for which minus x squared plus 6x squared minus 9x plus 4 is equal to k will have real and unequal roots. So they're asking to find the values of k, right, for which this equation here will have real and unequal roots, right? So you can look at this way. You can say, okay, I have f of x, which is equal to the left-hand side, which is this guy here, minus x cubed plus 6x squared minus 9x plus 4. That is your f of x. You know this, because they want you to find the values of k for which this equation will have what? Real and unequal roots. So you want it to have 3 distinct roots. So, yeah, so we have f of x to be that. So you can define another function to be k. So you can define another function, h of x, to be equal to k. You know that k is a real number, right? It is a real number. The examples of k, you can say h of x is equal to 7, right? Or your h of x can be your negative root 2, right? So h of x can be anything, because k is a real number. So I'm not fixing it to be 7 and that, but you want it to be a real number. So you know how this function looks like. You know it's a straight line, it's a horizontal line. H of x is equal to 7. Even this one is also a horizontal line. But if you draw this one, it will be above, it will be here. It will be a horizontal line up here. It will be a horizontal line up there. This will be your, it will pass at y is equal to 7. It will pass at 7. At 7. And if you're drawing this one here, it will be negative root 2. I'll say it's below the x-axis somewhere there. So if you draw it, it will be something like this. So the point is, this is a straight line, is a horizontal line, right? And this is a horizontal line, because you know a line is in the form y is equal to nx plus c. But if the line is horizontal, then the gradient is 0. So which means this line h of x is equal to 0x plus 7. But 0x is 0. That's why we just write it simply 7. The gradient is horizontal. You don't have any gradient. You don't have any slope. That's why we just write it like that. So now, I'm going to clean this part because I don't need it anymore. I'm sure you can get the point that if you have an equation like this, it is a straight line. Right? It is a straight line. Okay, so let's go. Let's continue. What are we doing? So now we have this function, which you know very well that it's a cubic function. And you have f of x, you know that it's a straight line. You want this function and this function to intersect, right? This is what you want. You want them to intersect. Because once you say you want this equation to have real roots, which means you want these two to have a solution, right? So you want f of x equal to h of x to have real solutions. What does that mean? It means that these two functions f of x and f of x and h of x are intersecting, right? And since you want them to intersect, you want the roots to be unequal. You want to have, I think I missed something. You want to have 3. You want to have 3 real and unequal roots. That's what you want to have. You want this function to have 3 real solutions. You want to have 3 real distinct solutions. You want to have 3 solutions and they should all be different. Right? Look at this now. If you can look at that y is equal to 7. If our k was 7 and you have h of x equal to 7, then look, our function h is only intersecting the red line once, which means you have one solution there. So here at this point you only have one solution. You want to have 3 solutions, which means your horizontal line, you want your horizontal line to cut your graph 3 times. You want your straight line, which is this, to intersect this guy 3 times. Why will that happen? Which means, look here, the coordinates for each of 3 and 4. So it should be turning somewhere here, maybe. Those are the coordinates for the turning point. So look, if I draw a horizontal line here, how many times is it intersecting? It's intersecting 1, 2, 3. Which is what I want, because I want this equation and this equation to intersect 3 times. So look, they intersect 3 times and at 3 different x values. This x value is different from this, different from that. If you draw another one down here, you can see they intersect 3 times. Here, here, and there. Draw another one here. Still intersecting 3 times here, here, and there. If you draw another one here, you can see it's 1, 2, 3, right? But if we draw one here at the turning point, let me draw with a different color. If I draw one at the turning point, I will draw it with orange. And if I draw this one here, y is equal to 4. How many times is our function? How many solutions are we going to have? We have 3 solutions, right? So you can see that you will have a solution at x equal to 0. You have at x equal to 0 here, you have a solution. And you have 1 here at x equal to 3. And you have 2 of them at x equal to 3. So you have 3 roots here, right? Also here, the roots are 3, right? But these 2 are equal there. You have 2 roots there. But same thing, even here at the x-axis. If you draw one here at the x-axis, you see that you will have 2 roots at x equal to 1, x equal to 1. And then you have 1 at x equal to 4. And this is not the situation that we want here. Because even though we have 3 real solutions, they're not distinct. They're not unequal. These 2 are equal. You want all of them to be unequal. You can only achieve that between 0 and 4. Because between 0 and 4, that's when your horizontal line cuts your graph 3 times at different points. And that's exactly what you want. You want to have 3 distinct solutions, which means your horizontal line must cross your cubic function at 3 points that are distinct. So if you draw one down here, you can see that you will only have one solution. Which is for values that are less than 0, you only have one solution because your horizontal lines will only cut your graph once on that area. Even for values that are greater than 0, greater than 4, you only cut it up there once, which is you have one solution. So in order to have 3 solutions, what does that mean? It means that your values of k, which means whatever this function is, if you want your function h of x to intersect this one 3 times, your h of x must be between your k, which is your h of x, must be between 0 and 4. So your k should be greater than 0 but less than 4. Because if your k is greater than 0, which means it's above, if it's less than 4, which means your function, your h of x will be between what? Between these values here. And you know, between these values, that's where your lines, your horizontal lines, will cut your graph 3 times. So that is the way, or one would write it as k, an element of 0 to 4. So at these values of k, for whatever value of k you get here that is in this interval, it will meet this function 3 times at 3 different points. And that's what you want. So you want your k to be somewhere here. So you want your horizontal line to be cut between these two, because it will intersect the graph 3 times at 3 distinct points, which is what they were asking. So this should be more or less like your solution. Done. So now we go to 8.4. So now we're doing 8.4. 8.4 reads as follows. The line g of x equal to, the line g of x equal to ax plus b is a tangent to f at a point of inflection of f. Okay, determine the equation of g. Let me read this again. 8.4. The line g of x is equal to ax plus b is a tangent to f at the point of inflection of f. Right? Determine the equation of g. So you're told that some equation g, which is g of x is equal to ax plus b, is a tangent, right? Is a tangent to f at the point of inflection, right? So they wanted to find the equation of the tangent. So the first thing that you need to find the point of inflection. Because if you want to find the equation of the tangent, you need the gradient, you need the coordinates, you need the coordinates of the point where you're going to find the tangent. Right? Okay. So, first thing that we need to find the point of inflection, where the tangent is. How do you find the point of inflection? Say x coordinate of the point of inflection is equal to x coordinate of the turning point 1 plus x coordinate of the turning point 2 all over 2. What was the first coordinate of the turning point? Was 1. Second one, it was 3 all over 2. So the x coordinate of the point of inflection is equal to 4 over 2, which is 2. That is the x coordinate of the point of inflection. That's where the point of inflection is. Right? Then now, what else? We need the corresponding y value. How do we find the corresponding y value? You say now, you substitute the x coordinate of the point of inflection to the original function. So f at 2 is equal to what? Equal to 2 minus 1 all squared times minus 2 plus 4. This is 1 times 2, so this is 2. The coordinates of the point of inflection are 2 and 2. These are the coordinates of the point of inflection. So we have the coordinates. We know where the tangent is sitting. It's sitting at that, it's going through that point. It's touching there. No problem. So now what do we need? We need the gradient, right? So we know that, I said this before, we need the gradient. So I said that the gradient, when we're finding the coordinate of turning point, I said the gradient, or the derivative of a function, gives you the gradient at a point, right? So the derivative of a function gives you the gradient at a point. So let's find the derivative of this. So f prime in x is equal to what? Minus 3x squared. You know how to derive now. Plus 12x, because I derived this before. Minus 9. I derived this at 8.2, 8.1. I found the derivative 8.1. Should go back, refer to that, and see how I found it if you are unclear. So I said this is the gradient at a point, right? That's what that is. It's a gradient at a point. So now we know the point, that the point is 2x is equal to 2. We want to find what is the gradient at that point. So how do we do that? We say, okay, f prime at 2 is equal to, so this is giving us a gradient at x is equal to minus 2, at x equal to 2. Once we know the gradient at that point, we'll be able to find the equation of a line. Because we know that this is the gradient, that is the y-intercept. So we'll know what the gradient is from this answer. Then we'll only need the y-intercept, and we use the coordinates that we have to find that. So what do we do? Say minus 3 into 2 squared plus 12 into 2 minus 9. So punch that and see what that gives you. So we say, okay, minus 3 into 2 squared plus 12 into 2 minus 9. So you find that f prime at 2 is equal to 3. So at x is equal to 2, the derivative gives the gradient at a point, right? So at x is equal to 2, the gradient is equal to 3. So you know that the gradient x equal to the gradient of f at x equal to 2 is 3. So you say your g of x, which is that, is equal to what? It's equal to a x plus b. This is a line. So this is the gradient. So your g of x is equal to 3x plus b, because this is the gradient. Because you know, the equation of a line is equal to y is equal to mx plus c. This is the same thing. This is your m, this is your c, which is that. So now this is okay, you're only missing g. That's where the coordinates 2 and 2 come from. So you say 2 is equal to 3 times 2 plus b. Then solve for b. Your b is equal to minus 4. Therefore, your g of x is equal to 3x minus 4. So this is the equation of a tangent at the point of inflection. And I hope it is clear. So let's go now. We move to 8.5. What are they saying at 8.5? At 8.5, they are saying, calculate the value of theta, the acute angle formed by G with the x-axis in the first quadrant. Right? So they want the angle of inclination that this line forms. That this line forms with the x-axis in the first quadrant. You know that this is 8.5, right? You know that m is equal to tan theta, right? Which is your angle of inclination. So n is equal to what is your gradient? Is 3. It's equal to tan theta. So theta is equal to arctan 3. So your theta is equal to what? Equal to the answer of this thing. Find arctan of 3. Came out to be 71.57 degrees. So this is the angle that this line is forming with the x-axis. So I think we should be done with this question. And I hope it is clear to you as it is to me. I'm done with this question. I'm going to go to the next question, question 9. Thank you for watching.